Hi guys, in this video we're going to be taking a look at Pytes' new battery, the V5. I've already previously reviewed their e-box version, which was a fantastic battery, and I have no doubt that they have upped the game on this one here. So the last battery that I had reviewed was a fantastic battery. We had military grade electronics in it, we had redundancies as far as the BMS. That battery was bulletproof. I'm still using that battery today. Now this battery is going to be a great addition, and I have no doubt it is going to pass all the tests I throw at it, and it is going to perform fantastic. So let's look at some of the stats of this battery. So we have a recommended charging and discharging current of 75 amps. We also have a maximum charging and discharging of 100 amps continuous. We have a peak discharge current of 101 amps to 120 amps, and that's going to be for 3 minutes. You can pull those kind of currents. And we have a peak discharge current of 121 to 180 amps for 15 seconds of a draw. So that is going to give you a pretty high surge capacity. Now looking at the front of the battery, we have an on-off switch and we have the startup switch. So this is going to be a soft start. So when you connect your batteries to your inverter, you're going to engage the soft start, and this is going to save your capacitors inside your inverter so that nothing breaks. Down here we have our dip switches for putting these batteries in parallel. This is going to identify which pack is which, corresponding with 1 through 6. You can put multiple batteries in parallel. Here we have our alarm light, our run light, and a light to show if we're charging or discharging. We also have a state of charge light here that's pretty nice. I'll start it up in a minute. We have our console RJ45 jack, a CAN jack, RS485, a port 1 and a port 0. These are going to be for parallel connecting the batteries. We also have a dry contact port here, multiple ones. And behind here we have a port for a Wi-Fi dongle, which unfortunately I do not have right now, so I can't show you this in action. But this is where the Wi-Fi dongle connects, and this will allow you to upgrade any firmware updates on the BMS, as well as do real-time live monitoring of your battery pack. So here is the positive and negative, and it's pretty neat. You've got a little button to depress on the side here, and then you have a little trap door to open, and there are knockouts top and bottom, whichever way you decide to route your cable, and that's going to be the same on the positive and the negative. Now with this battery in the box, we got these really nice solid copper tin plated bus bars, and these are going to be for connecting multiple units in parallel, and these are flexible and they have a nice heat shrink on them, so these are going to be for parallel connecting. We also have a RJ45. This is going to be for connecting your modules so that they can communicate with each other, as well as we have a grounding cable for safety. This Pytes battery also now has heaters inside of it. So this is going to allow this battery to stay at an optimal temperature range for best performance. The heaters inside this battery have a low consumption of 170 watts, which is not on continuously. It's only if you're in a cold temperature environment, but it uses 170 watts of power to heat the cells to keep them into an optimal running range. Another great thing about the Pytes batteries is the umbrella of certifications that they carry. They carry UL listings, they carry CEC, CGIP, UN, EIC, and CE standards. I'll leave them all on the screen here. And you know that if they can pass all those qualifications, this is going to be a great build of a battery. So this battery is rated at 6,000 charge cycles at 90% depth of discharge, which is to me unheard of in the industry. As well as we have a 95% efficiency round trip for this battery. That's fully discharged and charged again. We have a 10-year warranty, up to 20-year lifespan design. So this battery with lithium iron phosphate, calendar year degradation is going to kill the battery before the cells go bad. This is going to last a long time. And we actually have a product liability insurance that comes with this, and that is going to be for North America as well as Latin America. So the fact that they're standing by their product and actually giving you a liability insurance for the product is pretty amazing. So if anything happens, it's going to be taken care of. Let's charge it up and do a discharge test, and then we'll open it up and see what it looks like inside. I can't wait to see what it looks like with the cover off. Okay, I've got my battery set up here for my discharge test. Now I have my battery hooked through this device I made up that has a resistor built into it, so I could slowly charge the capacitors in my inverter. But with this battery, I'm not worried about it. I can just click it on and it will soft start and save the capacitors in here. And I'm going to be running it into a space heater because it is starting to get cold. We just passed New Year's, so I want to heat my shop. Perfect time to do a battery discharge test. Okay, so you can see there, I've got my voltage is lowering because it's just got a bit of voltage when I first plugged it in. But let's turn on the battery and see what happens. Okay, and I'm going to press and hold, and you should see the voltage jump up. And there you go, I heard a click inside the unit, and there you go, we're at 53.64 volts. Okay, let's check with my voltmeter just to verify. Okay, and I'm going to check with my voltmeter to see if we match the app. And we have 53.6, I have 53.62. And we will check the state of charge. We are fully charged, so this discharge test is ready to go. So I'm going to start by turning the inverter on. Okay, now it's going to get a little loud with this space heater. And our load is going up. Okay, and we are right around just above 26 amps. Still climbing a little bit, but it's probably going to land around 26, 27 amps of discharge. So I'm going to let this test run, and once the battery's fully depleted, we will get our amp hour capacity. So I will be back when the test is complete. Okay, and we are done the discharge test. So as you can see here, I have a red alarm light that's on. So we are completely depleted on this battery pack. And we have 101.555 amp hours out of the 100 amp hour battery. So this is legit, it passed. Now let's open it up and have a look inside. Okay, so we have two power packs here. I can see we have a negative, and then we have a bus bar that runs up over to the positive post here. This is labeled positive. And on the back side here, we have the positive that runs up right to the front here where the positive post comes out. And then on this side here, we have our negative with what looks to be two conductors that run down over into this board with two 6-gauge wires. You can see here, we got the 6-gauge. So they run down into this board and run through this board out to what looks to be here. So this is going to be what's coming out and running over and to the post that's on the front here. So that is very interesting. This is not a BMS-like thing that I've seen before. Here is the cables for the heat pads. So these are the cables for the heat pads. They run down underneath. They run over. Got two conductors here. And they're probably series connected. Run down. How am I going to get these modules out? I think these modules are bolted down with these bolts right here. So they're bolted down in all the corners. Here's some balance lead cables right here. And they run over to this board. And the second one here runs up in between the batteries over to the second pack here. So this is really nice. You can see here we have a board down here for the displays connected with some ribbon cables. So we're connected with ribbon cable here and here. This overall, where does this cable go? I'm not going to pretend like I know what all of this does. That goes to this front board up here. I'm not going to pretend like I know. We have some capacitors here. There's some MOSFETs down there. I believe that's for bleeding off any excess current to balance the pack. I couldn't tell you what all of that stuff is, but I want to try and get one of these packs out, at least one of them. And we even have these little caps here that was covering over top of the terminal for the bus bar that runs down for the series connection, and that is on every one. Well, I'm not sure how deep I really want to go. If I take that off of there, that's positive. The case could be negatively charged. Okay, so I'm going to disconnect the balance lead cables. I think I might be able to get one of these covers off and see the cells. So I'm just going to disconnect both of those. There's a little tab here, here, and here, and then 3 on the opposing side. So I'm wondering if I can actually just pop this top piece off to see the cells. Oops. Seems to be. Oh yeah! Wow! Look at that! Okay, look at this. That just looks really cool. So, it looks to me like this PCB board is laid in and then this is spot welded directly to the bus bar. Now, I'm not going to be able to get this off to see what type of cells these are. Can't get it off from that way. Can't get it off from this way. No. Oh, I really don't want to dig that deep into this battery. But there's a whole plastic piece on here. This is all laser welded. These are spot welded. So there's no way for me to be able to take this off in order to show you guys what cell manufacturer they're using. I have no doubt in my mind that this is premium cells. So let's take off this other lid. Okay, every laser weld looks great, every spot weld looks great. I can't see the heat pads. I believe the heat pads are going to be underneath. And I don't exactly want to pull this battery out. But I'm going to say that the heat pads are on the bottom just because of where the wires go in. Where would be a temperature sensor? Let's see if I can't find a temperature sensor. No way. I think it might be, maybe. We have 3 leads going there. Wow, okay, so this is kind of neat. Okay, hopefully this is going to show up on camera. Let me grab a red pen. Okay, so you can see here, so this is going to be the battery voltage sensing cable for balancing. So it's connected here. As you can see, we have 2 leads that come out and they squiggle and then they run down through the line. Now on a couple of them, like this one up here, there's a little device that's inside of this plastic. And you can see we have the lines here that run over normally with the Ziggy lines for the balancing. But then we have 2 additional lines right here. So I believe what that is a temperature sensor inside of this little bubble. We have one here, we have one here, and if I move down, we have one here. Keeping going down, we have one here, and then we have another here, and one up top here, and that's it, and then back to this one here. So, in order for me to do my cold temperature test, I believe that is going to be the temperature sensor. That is so cool. I've never seen anything like that before. So I'm going to go get a cold pack and we're going to try and put a charge onto this. So I need to get the battery to turn back on. So I'll put my 2 balance lead cables in. Is the battery going to turn on? Yep, there we go, it's on. Okay, let me readjust here. Okay, I'm now charging with 5 amps. Let's go get a cold pack and place it on one of those sensors and see what happens. You can see on the screen here we're flashing green and the state of indicator is flashing, so we're getting a charge right now. Let's go get a cold pack. Let's put this cold pack down on one of these sensors. Am I wrong about the sensor? Okay, I'm not seeing any change. Okay, let's try a different spot. The battery might still be too hot. I might have to do this test tomorrow to let the battery pack cool down. Because I can still feel they're pretty warm, the cells, from the discharge test. Man, I was so excited. Yeah, I'm getting some spots like 28 degrees, 29. So this pack is still a little warm from our discharge test. It's hard to cool because these temperature sensors are connected directly to the bus bar. So it's hard to cool it down past what the bus bar temperature is. I know another method that will work. Now I'm going to try flash freezing it with some duster. This is not the way I like to test my batteries because it flash freezes. It goes down to like -40 degrees. Okay, that should have done it for sure. Oh, we just had low temperature. I think we might have just had low temperature protection, but I wasn't on a sensor. Was it this one? Okay, fresh ice pack. Let's just try it with the ice pack. Actually, let's check too. It might just be limiting the current. Ah, there we go. So it seems like I'm only able to get low temperature protection, but I'm not seeing the heat pads come on. Okay, we're back charging. I have 5 amps going into the battery. Okay. And we have a really loud, annoying alarm. So I have 0.47 amps going in, and that's showing the same. Wow, that is really annoying. Okay, so we have low temperature protection, but I am not able to encourage the heating function. What am I missing? Am I missing something? The only thing I can think is maybe the heater function. As the battery starts to get cold, it'll heat up and keep it above freezing, and only when it's below freezing, it'll just cut off. But that doesn't make sense though, because every other heated battery I've worked with, once it gets below freezing is when the heat pads turn on. I'm actually going to email the supplier and see what his thoughts are, because I was unable to get the heat pads to engage. Not sure why not. So I'll look into that. I'll be back. Well, good morning. So this is day 2, and I've actually figured out the heating function. So on most heated batteries, the heating function doesn't actually turn on until it's below freezing and you're charging. This will actually keep it at the optimal temperature as stated on their website, and I can actually show you that. So normally when I do these heat tests, what will happen is the charger will disconnect and then just the heat pads will come on. But this here has a smart BMS. It will keep it at optimal temperature. It's hard to explain, but here I can show you. So over here I have charging at 5 amps, and on here I have a clamp meter that is on one of the cables for the heat pads. So once we start to see amperage on here, then I know there's current flowing through to the heat pads. So if I leave that there and I put this onto the temperature sensor, now charging isn't going to stop only when it hits below freezing. That's when the audible alarm turned on and we had a fault on the alarm. See if I can get that. And there we go. So right now you can see here we have 3.33 amps flowing to the heat pads. So currently the heat pads are on right now. So that is neat. What I was waiting for when I was doing the test before was the amperage to fall on the charging to only go to the heat pads, but this will still allow it to charge as long as it's not below freezing. When it's below freezing, that's when it cut charging and the audible alarm came on. If I keep this on here and we get below freezing, then it's going to disengage charging. So that is pretty cool. So now if I heat this sensor back up, you're going to see that amperage right there. So now the heat pads are turned off. So we actually got the heating to work. That's pretty cool. Okay, so I want to see how easy it's going to be to communicate with the Pytes battery and a grow watt. Now this is by Rich Solar. It's just painted different. Still uses the same protocol as far as their BMS and reading the information. So I'm on here on the grow watt section of the user manual, and we can see here on the pinout here, which I believe is either for the battery or BMS protocol for communicating. So it shows here that pin 3 has to be in the up position. So on the little dip switches here on the front, pin 3 is now up, and we connect from the CAN port to the BMS port. Now they give you the pin out here, as you can see, but basically I think that any one of these cables will work as long as they're pinned the same. So if you hold them side by side, you can see the colors, and 4 and 5 just need to be the same on either end. So that should work to plug in there and to plug in here. So I'm plugging into the CAN port on here and the BMS port on the grow watt. Okay, we should be good to turn it on now. So I'm going to turn the soft start. And there we go, we are now on. Heard the click. Okay, now let's turn the grow watt on. Or Rich Solar, however you want to call it. On the screen right now, we are flashing LI and we are in utility. Now we just clicked over, so we have power coming in. So let's change some settings here. SUB, I'm not sure that this matters, but let's just keep it. Setting 3 on appliance, that's it. And then 4 is disabled. So now number 5, let's change this to LI. And then 36 needs to go to, so this needs to go to 51. Okay, now I'm getting a fault of 0.4. I think that's because this battery is low. But you can see we are in LI utility, but we have a fault of 0.4, but I think that's just because we have a low battery because of the discharge test we just performed. So I'm going to turn this off, and then I'm going to hook up utility power to this. So give me a minute. Now I'm going to hook up utility power to encourage charging to see if we can't get that fault to go away. Fault code 0.4 is battery is too low. So the battery is actually giving a low voltage warning, which is great. So now that we are set up and communicating, you can see we have battery 1% because we just did our discharge test. So I'm going to let this charge up a little bit more, and then we'll see how this percentage here changes. But right now we have a fully communicating system. So our battery is now communicating with the grow watt. Just need to bring up the charge a little more because, again, we did our discharge test. And there you go. The fault light is now gone. We are good. No more red light because we are above 20%. So we are in the clear. So that's going to wrap it up for this video with the Pytes battery. I think it's a bulletproof server rack battery. Works great, communicates with all different kinds of inverters, lux power, grow watt, wide variety of communication ability. So this is going to wrap it up. They do have communications as far as to a console, so to a PC. They also have the Wi-Fi dongle for a Bluetooth or for a Wi-Fi app. But yeah, this is a solid battery for a great price. I think the PCB board inside, connecting all the cells and the temperature sensors and the heating, it's a really good price for a battery. So check them out. I'll leave links in the description below. And as always, thanks for watching. Bye.